we take a look, I thought I unfroze it. Your job is to write equations that model real-world situations. They're going to look like the down on the farm problems for those. So the first thing we want to do is identify the information you know. And if you look through the notes, that's often the first thing I ask, or the word problems, that's often one of the first things I ask you to do is identify what you know. So when we look at this problem, it says the number of recreational visits to national parks in the United States increases by about 9.3 million each year. In 1990, there were about 263 million visits. So what do I know? I know that they increase
9.3 million a year.
By 9.3 million per year. And then I know in 1990, there were 263 million. I had one question at one point, I think it was on the worksheet you guys had on Friday. Do I need to add all the zeros for millions? No, you don't, as long as both of these values are in millions. All right? So we've got three pieces of information, guys. When I have three pieces of information like that, I either have slope as a starting point, because 1990 is the first year, or I have slope in an ordered pair. So we need to keep reading from there. I guess I should tell, how do we know that this is our slope? I kind of jumped the gun there. How do we know 9.3 is the slope there, Maggie?
It has like a rise of a run.
It has a rise of a run, millions per year. And they also tell you that it's increasing. How something is changing, guys, either increasing or decreasing, that also tells us that we have our slope. So we're going to use this to write an equation that models the number of visitors, V. If you use X and Y instead of V and T, that's fine. But they do give us some variables to use here in terms of years. So they're telling us every year how much it changes. So that means this is your Y, this is your X. And let T be the number of years since 1985. It's what happens, guys, is I'm not actually underlining all the key information in the problem. I'm actually identifying it in part B. This is important because now I know 1990 isn't my starting point, is it? 1990 is one of my years. Well, how many years has that been since 1985? How would you figure that out? They want us to start in 1985. And we're in 1990. So how many years have passed? How would you calculate that? People doing 5. You just subtract, right, guys? I mean, it's just either it's counting or subtracting, one of the two. So I know that this is at 5 years, we've gone up to 263 million visitors. All right. So I'm not actually using 1990 as part of my ordered pair. I'm using 5 as part of my ordered pair because here's what I saw a lot of people doing. Y minus 263. So we have Y minus Y. Visitors minus visitors. And actually, I should change that to a V for you guys. Shouldn't we? Is equal to your slope, an increase in 9.3 times X minus 5. You have to have it in how many years have passed. And once again, Mrs. Woodard is the worst example at these because they don't tell us to use X. What do they tell us to use?
T.
T. And that kind of helps a little bit. I have V with visitors. I have T with time, with years, right, guys?
Yes.
All right. Now we can go through and multiply. I do use point slope form a lot with my word problems. 9.3 times 5 should give me 46.5. Now, I was able to do that multiplying. I will need someone's help with the adding here. I've got to add 263.
This is what our homework's going to look like.
Yeah. So who can do negative 46.5 plus 263 for me? They have a calculator out ready to go with that one? Anyone work ahead? Brooke? Beautiful. So I know that the number of visitors when we started collecting data in 1985 was 216.5 million, and it increases by 9.3. Now, could we have taken 9.3 and subtracted it from that 263, guys, until we got back to 1985? Could we do that just like we did our chicken problem and just work backwards from there? Yeah. Cameron?
I didn't get 216.5. I got 309.5.
You have to make this a negative. We need to be real careful here because this was minus 465, so we want to have it as a negative there. Okay? And what we know is and that's kind of our trick here. We know I've got to be less than 263 because I've worked up to that 263 million visitors. So I know my starting point has to be less. So that's one way you can kind of do a check on your calculator, guys, if you're not using point slope form. Cam,
Why didn't we keep our 9.3?
why did we keep 9.3? Because that was our slope. And so when they give you the slope, when they tell you how it's increasing or decreasing, you're going to keep that 9.3 all the way through the entire problem. All right? We don't see the 5 and we don't see the 263 because that was just an ordered pair. But the slope, we'll see that every single time. All right? How many people feel pretty good with word problems? Does this fit what we did with chicken? All right, so let's take a look. Predict the number of visitors in 2010. All right, I need to go to split screen here. They want me to predict the number of visitors in 2010. Well, how many years will have passed in 2010? How do I figure out how many years that is? Isaiah?
Going from 1990 to 20 years.
We'd have 20 more years, so we'd have to add 20 more years onto this 263, right?
Mm-hmm.
So one way of doing it is to do 20 times 9.3, because that's your increase, right, guys? And then add that on to the 263. That's one way of doing it. Seth?
25.
Well, the other way of doing it is, if we're looking from 1985, it's going to be 25 years, correct? And so the way we would use the 25, Seth, is to actually plug 25 in for t in that equation. So there's two ways we can do it. If we look at it from how Isaiah did, I have to add that on to the 263. If we look at it how Seth did, and we look at it from the starting point of this problem, I can simply take 25, plug it in for t, and add that on to 216.5. Does the work look very similar for both of those ways, ladies and gentlemen? Are they both getting multiplied by 9.3?
Yes.
Are they both getting some value added onto them? Yeah, you just have to decide which one you're starting at. Both methods will give us the same answer there. So I'm going to do the one that Seth has there, 9.3 times 25 plus 216.5. And we get 400. You have to add million on those, ladies and gentlemen. That will not show up on your calculator. Because if only 449 people went to the national parks, they would close down that entire system. So 449 million sounds better. And then we do have visitors. All right? But we do have quite a few options for starting these problems. Let's flip over to the back side. Whoops. Wait, if I put it up there, are we okay with it up there? All right. So we know a taxi cab ride that is 2 miles long costs $7. So 2 miles cost me $7. I know one that is 9 miles cost me $24.50. Ladies and gentlemen, do they at any point tell me what the cost per mile is? No. So they haven't given me slope and a point. What have they actually given me here? They've given you 2 points. And it's pretty obvious, guys, because how many pieces of information did I underline? 4. So I know 2 miles is $7. And I know 9 miles is $24.50. If you can identify the information you know, guys, and write it in an organized way, does it give you a way that it's kind of natural for finding slope? We either put it in a table, and you guys have been finding slope from a table, or put it as ordered pairs, and you've been finding slope from ordered pairs. But that's what we have to do first, is we have to find slope here. We're going to have to do some subtracting. So I'm going to work down here under part B, because it says use the information to write an equation that models the cost in terms of the number of miles m. Okay, so I'm going to have to find my rate of change. So I have 2450 minus 7 over 9 minus 2. So this should give me 7 miles difference. So I went 7 miles farther. And it cost me $17.50. Not a very nice slope at all, ladies and gentlemen, is it?
No.
So based on what I've been telling you about slope from the very beginning of chapter 4, what do you think I want you to do with that ratio?
Change the fraction.
turn it into a fraction, or at least start simplifying it, right, guys?
Mhm.
So what is 1750 divided by 7? What's 1750 divided by 7? 2.5. I actually love 2.5. I'm not going to write it as a fraction. And here's why. Guess what I can add to the end of this? A 0. Now what does that look like? $2.50, correct, guys? And does money make sense in a taxi cab problem?
Yes.
Yeah, that means this is $2 per mile. Do I now know my rate for this situation? Yeah. And so sometimes, guys, you're going to have to step back and think, do fractions make more sense or do decimals? Now that you know your cost per mile, guys, we now need to take a look at, does that make sense? Well, I have some students that go and take $2.50 times $2.50 per mile and multiply it by the 2 miles. Well, guess what they get when they do 250 times 2? They get 5. That's not the $7 that we have here, is it? Because there's going to be a B value, ladies and gentlemen. They charge you money just for getting that taxi cab. So you're not going to be able to just stop the problem there with your slope. You still have to go through and find your starting point. So whichever way you want to find your starting point, I'm going to do it the way that I just did. I'm going to use this piece of information and said $7 is equal to $2.50 times 2 miles plus some starting amount of money. You could use point slope form. You can start with y equals mx plus b. You guys just told me that this is $5. So what do we know the b value has to be here? $2. Subtract the 5. Do your mental math. You know that b is equal to 2. Well, now I have a slope, and I have a starting point for that taxi cab ride. So I know y is equal to 250. Actually, Miss Woodard needs to do a better job of modeling this for you. The cost of your ride is equal to 250 times the number of miles plus a $2 starting point. Okay, guys? So don't assume every situation is what we would call a direct variation. Just because you know the cost per mile doesn't mean it's the end of your equation. Well, I think we have a couple of problems that we want you to answer. What does the slope stand for? Have we already kind of answered that here, guys? What does the 250 stand for? How would we put that into words? The cost per mile. Good job. What does the y-intercept stand for? Well, we've talked about that a lot this year already. What does the b value stand for? Ethan? Yep, the starting cost. And how would we figure out how much a 30-mile taxi cab ride costs? Well, what do I have to multiply the miles by? What's my cost per mile? 2.5. And what was my starting cost? Plus 2. Aren't I just plugging 30 in for m, ladies and gentlemen, in our original equation that we wrote? Yeah, 250 times 30 is going to be, what, 75? Make sure you label it as $77. Here's my expectation for you tonight, ladies and gentlemen.